Welcome to my educational video on molecular geometry. My name is Lillian Freeman, and today we will be discussing bent angular molecular geometry consisting of two atoms bonded to the central atom and two lone pairs. This setup creates three regions. Bent angular to molecular geometry looks like this. As you can see here, this geometry consists of two atoms bonded to a central atom and two lone pairs. These bonds are spaced less than 109.5 degrees apart, making it symmetrical down the middle. Remember that these geometries are found in 3D space. These geometries are seen in equations written in the form AB subscript 2 E subscript 2. We'll be using a dihydrogen monoxide molecule H2O water molecule for an example. To start, you must first make a Lewis dot structure of this molecule, which will look like this. Because hydrogen atoms only need 2 valence electrons and oxygen atoms need 8 for stability, the model will look this way. With the hydrogens on the outside, we know that the oxygen must be in the center, as the hydrogens can only have those 2 valence electrons. In the geometry, you will see that the bonds are spaced out equally to make this symmetrical geometry, and each of them, again, is less than 109.5 degrees apart. The two lone pairs on these molecules offer additional repulsion of the hydrogen atoms, and it makes them more compressed than you would see in a bent angular molecular geometry with just one lone pair. To determine the polarity of the H2O molecule, you'll need to use one of the periodic tables that denotes the electronegativity of each atom. To determine polarity, you would subtract the electronegativity number of hydrogen, which is 2.20, from the electronegativity number of oxygen, which is 3.44. Because when you do this math, you get between 0.9 and 1.5. The bonds are polar covalent to between each atom. The polarity of each atom will then be shown within the molecule using the delta plus, delta minus signs. The delta plus sign shows partially positive, less electronegative molecules, and delta minus shows partially negative, more electronegative molecules, as seen in this picture. In this example, there is an equal sharing of electrons, and a dipole is noted here with 2 arrows pointing in the same direction. Because there is a dipole, this means that this molecule will be polar, thus making the bent angular with the two lone pairs polar in this example here. I hope this video has been helpful to you as we've discussed the polarity and molecular geometries of the bent angular atom with 2 lone pairs. Thank you for watching.